In this programming example, I'm going to show you the amazing feature of short circuit for the logical operators. We have three variables, a initialized with -1, b with 10, and there is another one, c. And we have this expression here where ++a and ++b is evaluated and assigned to the variable c. Now, AND operation is left to right associative. That means the left hand operand is going to be evaluated first, and then the right hand operand is going to be evaluated. Then the AND operation takes place. So if we go on with that, we can just guess the output by evaluating the expression manually. So first of all, ++a is going to be evaluated. This is pre-incrementation. So it's going to be 0 here. That means false. And then it is ++b. That's going to be 11 here. True. And we know that false and true is going to be false for the AND operation, and so therefore 0 is going to be assigned here to C. So we can expect the output to be something like this: C as 0, A as 0, and B as 11. I'm just executing the program and showing you that I'm fairly correct with this. Let me just execute the program. Here we go. Oops. It seems that we have made a mistake here because our expectation is not at all with the output. So here we expected C to be 0, so C is 0, correct. A to be 0, A is also 0, that's also correct, but we failed with B. The value of B we expected to be 11, but here it is 10. Now why this is so? In order to understand this, we need to understand the short circuit feature for the logical operators, and it's pretty logical actually. What happens here, we know that if either of the condition for the AND operation is false, then the result of the AND operation is false. And since the AND operation is left to right associative, so if it sees that the left hand operand is 0, that means false, it never evaluates the right hand operand, because whatever the result of the right hand operand is, the result for the AND is always going to be 0. So in this case, since ++a actually evaluates to 0, that means false, it doesn't look at all to this ++b. So ++b is never evaluated, that means the value for b is never incremented. That's why 0 is assigned to c, and this is not evaluated, so b remains to 10 and a is incremented to 0. Now had we initialized a with something else, say 5, then ++a would actually increase the value for a to 6. That means non-zero value, that's true. In that case, if the left hand operand is true, then it is going to evaluate the right hand operand. Then it needs to check the right hand operand for the result of AND operation. So the AND is now going to check for the evaluate for the right hand operand. So B is now going to be incremented to 11. Let me show you the result. So now the B is incremented to 11, and obviously A is 6. Non-zero value and non-zero value, that means true and true. The result is true, that's 1. C is 1. So the case is same for the OR operation as well. If we have something like this, say OR ++b, and we have here say 0. Now ++a is going to increase the value for a to 1, and 1 is true value. Now for OR operation, if the left hand operand is true, then always the result of the OR is true. We know that if one of the operand for the OR operation is true, then the result of the OR is true. So it's again left to right associative. So if the left hand operand is true, it's never going to check the right hand operand at all. So in this case also, the ++b is not going to be evaluated, and the value for b is going to remain 10. But a is going to be incremented to 1, and the result is going to be 1 for c as well. Here we go. You can see that b is 10, c is 1, and a is 1. B is never incremented to 11.